question is about finding the resultant force of the given forces. It's in 3D format. When you want to solve a problem like this, first inspect the configuration of each force and see which angles or which geometrical parameters are given. In this particular example, F1, which is this one, you can see that it's acting in an XY plane. Therefore, it doesn't have any Z component. And also, F2 is acting on YZ plane. That means that it doesn't have any X component. But when we look at F3, it's floating on air and alpha, beta, and gamma for it is given. Therefore, it's going to have all three components. So the best way to solve this problem is Cartesian format. In Cartesian format, step 1, break each force into its components. Let's start with F1. F1 is equal to 1400 cosine 40 degree, because adjacent to x is cosine 40 degree and cosine is for adjacent, and it's going to be 1400 sine 40 degree in j direction. And like I said, we don't have any z component. You don't need to write it, but I'm writing it so that you can see we don't have any force acting on z direction. Now, if you solve this, it's going to be 1072i plus 899j plus 0k. Then the same step, but the second force that we have is F2. For F2, you can see that forces parallel, a triangle parallel with xy, and F2 itself is given. Therefore, F2 is going to be 900 times parallel with y is 4. Therefore, 4 over 5 times. This is going to be in j direction, and 900 times 3, which is parallel with z over 5 in k direction, and we don't have, or we didn't have any x. Therefore, x is 0. So I'm moving this back and I'm writing 0i plus. So F2 is going to be 0i plus, if you multiply it, it's going to be 720j, and this next one is 540k. And the same with F3, but F3 is easier because alpha, beta, gamma is given. You have to just multiply the force to cosine of each one of those angles. So cosine 100 is alpha, therefore it's I, plus 1200 cosine 50, which is beta, is j, and 1200 cosine gamma, which is 45, and that's the angle with z, therefore it's k. And if you multiply it and simplify it, it's going to be 208i plus 771j plus 848k. We have all three forces written in Cartesian format. Now we can add them to each other because we have I in each force, so I, and I. And we have J, and J, and we have K, and K. We can add I's to each other, we can add J's to each other, and we can add K's to each other. And by adding them, we can form the Cartesian format of the resultant force. Usually problems ask for the Cartesian format of the resultant force. So it's going to be 864 I, if you add them to each other, plus 2390 J plus 1388 K. This is FR in Cartesian format, and it's a vector. Now, the next step, so this was step 2. The next step is the same force, but the magnitude of the force. And in order to find it, we can use the square root of the squares, means 864 square plus 2390 square plus 1388 square. If you solve it, it's going to be equal to 2896 pound, or we can just write it 2.9 kips. So you see that this is a scalar value. It's not a vector, it's a number. Now, it's asking for the direction of the force. So direction of the force means finding alpha, beta, and gamma. Alpha is cosine reverse fx from fx over fr, and that's equal to cosine reverse fx is 864 divided to 2896. Don't forget, I'm going to highlight fx, fy, and so this is our fx, this is our fy, and this is our fz or fk. So solve this, it will give you the angle equal to 72.6 degree. Beta is cosine reverse fy divided to fr. Some places they call this cosine reverse as arc cosine, which is arc cosine, pretty much. 2390 divided to 2896, and it's equal to 34.4 degree. Should draw a line in here. And gamma is equal to cosine reverse fz divided to fr is cosine reverse 1388 divided to 2896 equals 61.4 degree. And this is how you can solve and find the direction of this resultant force, which is showing the angles with regard x, y, and z.